Good morning everyone. So I am Usha Bhardwaj, Assistant Professor of ECE Department. So today we are going to learn about uniform plane wave and the subject name is Electromagnetic Waves. So let's start with the overview of uniform plane wave. So what is uniform plane wave? So uniform plane wave is a fundamental concept in electromagnetic and wave theory, which means it describes an idealized electromagnetic waves that travel through the space or through any medium, which could be air, atmosphere, etc. So uniform plane wave is a wave, electromagnetic wave, in which electric and magnetic fields and magnetic fields are constant and perpendicular to the direction of propagation of our signal, of our wave. So it means if this is the direction, so our electric and magnetic field both will be perpendicular to the direction of propagation. And the main point is, at every point wherever the propagation occurs, the wave signal strength is equal or constant at every point of the time, every point of phase. So let's discuss about definition. A uniform plane wave is a type of electromagnetic wave in which the electric and magnetic fields are uniform, as we discussed earlier, and constant over any plane perpendicular to the direction of propagation. So here are some applications of uniform plane wave. Uniform plane waves are idealized models but are extremely useful in understanding and designing real-world electromagnetic systems, which means the systems which are based on EM waves or electromagnetic systems, their UPW, which means uniform plane wave, is very effective. So here are some applications. Electromagnetic waves propagation. UPW are used to model how EM travels through a free space or materials. Helps in studying radio waves and microwaves. Okay. So what is electromagnetic wave propagation? Where UPW or uniform plane wave is used to model how EM waves travel through the air, or through atmosphere, or through space. Okay. So next one is antenna theory. Antenna theory, which means it simplifies the analysis of radiation patterns and antenna performance, which means it simplifies the radiation pattern. So for example, this is the direction of propagation. So that's the curve which is called as main lobe. Here are some scattering or some loss of signal, and this is back lobe. So these are side lobes and this is back lobes. Okay. So this is the radiation pattern of signal. And the antenna theory and antenna performance. So if the antenna performance depends on the efficiency of the input or of the signal or of the device, which means the input which is fed is directly proportional to the radiated power, which means our input is the ratio of radiated power. So next one is waveguide and transmission lines. UPW describes models of propagation. It could be rectangular or circular waveguide, coaxial cables, microstrip lines. So how we transmit it? It could be rectangular waveguide, it could be circular waveguide, or it could be coaxial cables. So let's discover what is coaxial cable. Coaxial cable, nowadays DTH, if we know about the DTH, that is direct to home antennas, used everywhere. So here there is a parabolic reflector which receives signal, and there is a LNB. Whenever the signal is fed on this parabolic, they reflect back to the LNB, and LNB collects all the signal and convert it back to that radio waves or that EM waves into electrical signals, and then fed through the coaxial cable, that is coaxial cable, to our set-top box, and which is connected to our TV. Okay, which means the LNB, that is coaxial cable, that is set-top box, and this is connected to TV. So that is set-top box. So that connecting wire is called as coaxial cable. So here are some more applications. Optical systems used to study light as a plane wave and used to laser beams, used for laser beams, used for interference and diffraction experiments, and fiber optics. Here are some characteristics of uniform plane wave. A uniform plane wave is idealized electromagnetic waves with simple and well-defined behavior. Here are its main characteristics because it has simple and well-defined behavior. This is the direction of propagation everywhere. If you see, it is constant in every phase. So planar wavefronts, the electric field and magnetic field are uniform in plane and perpendicular to the direction of propagation, as we discussed earlier. All points on the wavefront experience same phase, and transverse nature. Obviously, transverse nature, electric and magnetic fields are perpendicular to the direction of propagation. So that was it for today's class. Thank you so much.